Hello and welcome back. Direct and indirect problems on a spherical datum is very similar to what we explained for the planar datum. But the difference is that here we use a spherical triangle instead of the planar triangle. And similarly, we have coordinates of a point, point I, for example, some quantities between this point and another point J are measured like geocentric spherical distance and azimuth, and we want to determine the coordinates of the point J. But in indirect problem, we have coordinates of both points and we want to compute the azimuth and the, the spherical geocentric angle. Let us now talk about the direct problem. You have the spherical triangle on the left side. The unknown quantities that we are going to determine are in red, as you see here. The quantities that we have already know are the coordinates of the point I, as you see here, and the blue ones are the quantities that measure between the points. Means that these two quantities connect this point known point I to the unknown point J. But how can we determine the coordinates for the J? So if I write cosine rule for this arc, you could hear from north to J, I can write cosine of this arc is equal to cosine of the other arc, cosine of this arc plus sine of that arc and sine of this arc multiplied by the cosine of the angle between them, or the angle in front of the arc north to J. As you see the formula here. And why I have written this, use this cosine rule, because phi is known. This arc is also known, and the angle between them is also known. And the unknown is in front of this angle. Then simply all the things that I need for computing this arc are available, or I have. So cosine of 90 degrees minus phi will be sine. Similarly here. And after solving this equation for phi j, I get this formula. Therefore, that's simple. If I have the geocentric angle, the azimuth, and the coordinates of the point I can get phi, or the latitude of the coordinate j. For getting the longitude, look at what we have here. We have this angle, or the difference between the latitudes of the points, and the arc, the geocentric angle, or the arc in front of the north is known as well. Azimuth is known, and now I have already computed the phi, or the latitude of the point J. So I can simply write sine using the sine rule like that. Sine of this angle over the sine of the arc in front of it, which is this one, equals to sine of this angle, which is the azimuth, over the sine of this arc, which is in front of the azimuth. So if I solve this equation for phi, for lambda I minus lambda j, lambda j minus lambda I, take the arc and put the unknown one, take the unknown lambda to the left, we get this formula here. So I have computed the coordinates of the unknown point J. So that's the direct problem. Now let us solve a numerical example. Consider that the geographical latitude and longitude of a point are pi 55 degrees 10 minutes and 23 seconds and lambda 3 degrees 14 minutes and 23 seconds on the surface of a sphere with a radius r, as you see here. And the point is that if the azimuth and the curve length between this point and another point is 25 degree 59 seconds and 59 minutes and 55 seconds, and the curve length is 1,500 kilometers, what will be the latitude and longitude of the other point? Since we have the curve length, then we have to change it to the spherical geocentric distance. And we know that the mathematical relation between the spherical distance or the curve length and this geocentric angle in front of that curve is this. So I simply solve this equation for psi, or the geocentric angle between the points, and you will get this. And 1,500 kilometers is one. As you see here, I have written this in meter because r is in meter, or you can write both of them in kilometers, but the units should be same. So I will get this value in radian, and I can change it to degrees by multiplying it with 180 degrees divided by pi. So that's not a problem. Phi j, or the latitude for the point j, is this one. We have already shown that is how to derive this formula. I just insert the values. Phi I have, psi I have now here, phi r here, psi here, and the azimuth is the angle between the arcs, or the angle in front of the arc containing phi I. So if I solve it, I will get this value for phi, or latitude. For the longitude, we have already derived the formula. Just insert the numbers here. Insert the values for lambda I plus, and we have the arc sine here, a sine of the spherical angle, geocentric angle between the points, the azimuth, and the pi of the latitude of the other point. So if you solve it, you will come to phi lambda j. It's 18 degrees, 90 minutes, and 220 seconds. As I explained before, the indirect problem on the surface of a sphere means that we have coordinates of both points, and we want to determine the geocentric angle between the points and the azimuth. So, as you see in the figure, in the green ones, these are the quantities that we already have. And the red ones are those we want to determine. So, let us start with this arc, which is in front of this angle. Since we have this angle, as we have the coordinates of the points, and we have this arc as well, the other arc as well, and the angle between, therefore we can simply apply the cosine rule in spherical trigonometry. So if I write the cosine for this angle, for this arc, I get cosine of the arc is cosine of this side times cosine of the other side plus sine of this side, sine of the other side or arc, and the cosine of the angle between them. So if I simplify this, I will come to this formula. That's simple. Now I can solve this equation for psi by j. And I get the spherical geocentric angle between the points. In order to determine the azimuths between the points, we can use either cosine or sine rules. So let us consider the sine rule first. Sine of this azimuth or this angle over the sine of this arc equals to sine of this angle over sine of this arc. So if we simplify this equation and solve it for sine of ij, we get this. So if we want to use the spherical angle that we have already computed, we can use this formula. And later, we can take the arc sine of the right-hand side here, this tab, to get alpha, or the azimuth. We can also use cosine. I write cosine of this arc equals cosine of this arc cosine of this arc plus sine of this arc, sine of this arc, and cosine of this angle, which is in front of this arc. So if I simplify this formula, I get this. And now it's time to solve this equation for cosine azimuth, cosine of the azimuth. And you will get it. So we can use either this formula or this formula. But if we want to have a formula free of psi or the geocentric angle, or a formula which is only dependent on the coordinates of the points, that's simple. We should write this equation over this equation and get the tangent. Then I have to simplify the result until we come to this formula. As you see in this formula, there is no psi alpha. You can directly insert latitudes and longitudes of the points there to get tangent of the azimuth, or you can take the arc tangent from both this side, from this value, to get alpha, to get the azimuth. Now, let us solve another example. Here we have the same phi I and lambda I as previous example, and phi j and lambda j are those I had already computed from the previous example. On the surface of a sphere with the radius of r. Now the point is to compute azimuth and a spherical distance between the points. So I just compute psi because I need it later. Psi, I have already derived the formula for it. And if I just insert the numbers, I get psi, this angle, which is exactly the same angle that I already had in previous example. Now I change this angle to radian unit. And based on this curve length formula, I multiply this angle to the radius of the sphere and get 1,500 kilometers, as we already know that. For the azimuth, I use here the formula for the azimuth that I draw. And here you see that I have the sine, I have the cosine here. And just insert the numbers, insert the latitudes and longitudes with the formula, and I get exactly the same azimuths that I had in the previous exam. This means that both of the formula are correct. All formulas are correct.